Hello, and welcome back. In this installment, we'll be looking at the use of RC time constants in conjunction with a 555 timer in order to adjust the output of a couple of different types of circuits. So let's get started and look at our first circuit. So here's our first circuit. When we apply a load to the trigger of pin 2 of the 55 timer, we get a high output on pin 3. How long 3 is high is dependent upon the RC time constant set up by R1 and C1. In our first example, we'll use 200K and 10 microfarads for a 2-second high. And then in our second example, we'll use 200K and 100 microfarads to give us a 20-second output on pin 3. And we'll be lighting an LED to demonstrate this. Good day. Welcome back to the shop. Today we're continuing to build on the idea of the RC time constant and how we can use capacitors to set different timing circuits. And today we'll be introducing a new little friend, a powerhouse in the electronics world, and if we can get it to focus, oh, there we go, the 555 timer circuit. It's used in all kinds of things, and it has a bunch of different timing applications. Oh, focus. There we go. It can be used in a couple of different ways. One way is a one-shot or monostable timer. This is where we give it an input, and then the timer will go for a preset amount of time. Now the time is set up based on these two little units here, our capacitor and our resistor. Here I've got a 200K resistor, approximately, and a 10 microfarad capacitor. And when we do the math out on that guy, that gives us roughly a 2-second time. Now, 2 seconds isn't a very long period of time. So, for any sort of accuracy, I need to press this button the same time I press this button. And I am not the best at this. But we'll see. That's awful close to 2 seconds. I think it's awful close. Let's see if we can do it again. And yeah, sure enough, that gives us approximately, within a human finger margin of error, of 2 seconds. Now if we take out this capacitor and replace it with another one, so we'll take that 10 microfarad, toss it away, and we'll trade it out for 100 microfarads. So now, I just got to make sure I hook it up properly. Don't hook it up right, it's not going to work right. Now when we do out the math for 200,000 ohms, 100 microfarads, that's going to give us approximately 10 times the amount of time, or it should give us approximately 20 seconds worth of on time. So let's try it. I was a little shy there. Let's try that again. So let's try our 100 microfarad capacitor, which should give us 20 seconds, and see if we can get these at roughly the same time. That was pretty close, and we'll let the timer run. And again, we're going much longer than 2 seconds, so that's a good sign. We're halfway there, a little better. Coming up on 15, 18, oh, and we're just a little bit shy. Again, this might not be exactly 100 microfarads, I didn't measure it, and this might not be exactly 200,000 ohms. And again, I did not measure it, I just used the nominal values. So, that's a demonstration of the monostable timer. Again, if you had to be much more accurate, you would use a variable resistor, a potentiometer, something along those lines, so that you could adjust the circuit to get exactly the amount of time that you require if it's a need for it to be that precise. You'd have a trim pot in there. The The second main use for the 5-5 timer and our RC time constant is to generate a pattern. Now you can generate all kinds of patterns with a different, what they call duty cycle. Here, it's roughly a 50-50 duty cycle where the red light is on the same amount of time approximately as the green light. Now you can adjust that. The circuit gets a little more involved, where you can have one on for a much longer time and one on for a much shorter time. And then you can also adjust how fast they flash by adjusting your RC time constant. Now in this case, the RC time constant occurs between these two resistors in series that are also in series with this capacitor. So here I have approximately 330 k ohms, and I have a 1 microfarad capacitor, which gives me about 1/3 of a second for my flash rate. Now, if we cut this approximately in half, I don't have exactly a 1/2 microfarad capacitor, but I do have a 0.47 microfarad capacitor. And if I put that in, you should see the flash rate has dramatically increased. So now they're approximately about 1/6 of a second flash rate pulse width for them each. Now, if I was to take this little 0.47, and again, just for reference, we'll take a look at our 1 microfarad capacitor. We'll get back to our approximately 1/3 of a second each flash rate. We'll change out this 1 microfarad and we'll up that by a factor of 10. And we'll put this guy in. And now we have a much, much longer pulse width. So by adjusting our RC time constant, we can adjust our timing circuits. And we can either have something come on as a one shot, which only comes on when we tell it to, and then it'll reset itself. Or we can have a square wave generator or multi-vibrator, as in this second example. So here's our second circuit schematic. Now it's set up to make a square wave, but you can make other configurations and different input circuits to give you different types of output patterns, like a sawtooth wave. It's really very flexible. You can do quite a bit with this little 555 timer. Our timing circuit is made up of the combination of R1, R2, which in this case works out to be a series sum of 333K, and C1. And when you do the math out on that, that gives you 0.3333 of a second, or approximately 1/3 of a second, which means the output alternates between a positive and a negative, positive and a negative. So when it goes positive, LED 2, which is my green LED, goes high or on. And then when output 3 goes low, well, that's when my LED 1 or my red LED turns on. So as the pulse changes from positive to negative, that's how it actually turns on the two different LEDs, LED 1 and LED 2. Here you can clearly see the square wave that's being generated by our, where are you, bud? Our little square wave oscillator 555 timer circuit. And I'm only looking at the output on the green LED. And again, it's generating a really nice 2-volt square wave. Again, green LED, approximately 2 volts-ish output. And 200 milliseconds per division. And again, we're around 1/3, so it's a little bit longer than that, so it's almost perfect. So there you have it. Well, I hope you found this informative. If you enjoyed the video, don't forget to like and subscribe for other great stuff, and check out our YouTube channel to see what other electrical monkey business you can find there. Thanks for watching.